Until 2013, a unique new research project is being realized north of the European business and science metropolis of Hamburg, an international institution that will become the #1 address for top-class researchers from all over the world. Between the site of the German electron synchrotron DESY in the Hamburg district of Bahrenfeld and the neighboring town of Schenefeld in Schleswig-Holstein, the almost 3.5-kilometer-long European X-ray laser XFEL is being constructed largely underground. The XFEL will be the brightest X-ray light source generating ultra-fast light flashes on Earth. The underground experimental hall will be connected with the central supply station on the DESY site at a depth of 6 to 38 meters. Another access point will be located in between, on the XFEL site Osdorfer Born. a €1 billion investment into the future. This facility, unique worldwide, will enable researchers to film chemical reactions, map out the atomic details of molecules, and take three-dimensional snapshots of the nano world. The X-ray laser will be able to bring the conditions of the cosmos right into the lab. The European XFEL is a joint international project with a strong connection to DESY, which receives substantial funding from the German Research Ministry, the city of Hamburg, and the federal state of Schleswig-Holstein.
We open with this very complex instrument a view into the innermost functioning of molecules, of atoms, of chemical processes which otherwise would not be possible, and therefore we need that instrument.
The European XFEL generates X-ray radiation that opens up previously unexplored dimensions. More than 100 years after the discovery of Wilhelm Conrad Röntgen, a radiation source is now being realized in the metropolitan area of Hamburg that will provide a peak brilliance 1 billion times higher than that of the most modern X-ray sources, with results unimaginable today. The XFEL X-ray laser flashes are so short, for instance, that they can be used to make movies of chemical reactions. Exposure times of only a few thousand million millionths of a second guarantee that nothing will be blurred. Until now, researchers from all over the world could only dream of such experimental possibilities.
And I think it's very important now that a major breakthrough is taking place in this field, that Europe is there, and is there since the very beginning. So we think it's very important that such a project is realized not only in the United States and in Japan, but also in Europe.
The European X-ray laser will attract scientists and students from various scientific disciplines to northern Germany. The performance of the XFEL will benefit a wide range of natural sciences, from physics and chemistry to materials science, geological research, and the life sciences. It will also open up new perspectives for industrial users. For example, for the development of new materials in the nano world, with dimensions measured in billionths of a meter.
All we know about the universe, we know from radiation emitted by atoms and molecules in the stars in the interstellar medium. And these atoms are in very exotic states, which we can study with the FEL in the laboratory. Knowing the properties of these exotic atoms better will help us to interpret better the radiation coming from the universe, and so maybe help us to better understand what's going on there, and maybe even what's about the origin of the universe.
This machine is used, as I said, as a fast camera to see the motion, to make almost a molecular movie of the action, for instance, of biomolecules when they perform their function. From this knowledge, we hope to be able to derive the information to produce one day new pharmaceutical products which may help to fight some diseases.
In the experimental hall of the European XFEL, researchers will be able to explore the rules of the game of life in the greatest detail. The XFEL will enable them to follow the motion of biomolecules and the progress of chemical reactions in real time, which will allow them to better understand atomic processes. This will also help improve everyday life, for instance, through more effective medicines, or more environmentally sound exhaust filters and catalytic converters. A worldwide challenge.
The fact that we work as an international collaboration is both a necessity and a desire. The necessity comes from the fact that you need sometimes to pool the knowledge of all experts around the world in order to make real progress. That is what happened here when we built the accelerator part of the XFEL. The desire comes from the fact that it is very inspiring to work with international partners because everybody has his or her own idea, and together these ideas stimulate progress.
The start of the construction work in Schenefeld and Hamburg in early 2008 marks the beginning of one of the greatest scientific challenges of the century. The European XFEL facility will seek out the answers for the life of tomorrow. Starting in 2013, the international research community and DESY will meet that challenge. Welcome to the light of the future.